These are the solutions to the questions at the end of lesson 10.1. Now, number 1 is C. Number 2 is A, since if the slit decreases, the pattern must spread out. 3, we have E. The wavelength of sound is about the same order of magnitude as us and the things around us, so we see diffraction there more. Now, number 4, we have a slit width of 5.6 by 10 to the minus 4 meters, distance to the screen of 4 meters. We have our distance to the first dark fringe of 3.5 millimeters, and we want to know the wavelength. Now, we have A sine theta equals m lambda. Now, for first dark spot, m is 1. So we have lambda equals A sine theta. And so we want to know sine theta. We make the usual approximation. It's about tan theta, which is y over d, which is 3.5 by 10 to the minus 3 over 4, which is 0.0000875. So that gives us a wavelength equals A, which is 5.6 by 10 to the minus 4, times 0.00875, which is 4.9 by 10 to the minus 7 meters, or 490 nanometers. Now, number 5, we know wavelength is 675 nanometers. It's the first order. Now, in the first part, we have a slit width of 1.8 by 10 to the minus 4 meters. Now, we have A sine theta equals just lambda, since m equals 1. So sine theta equals lambda over A, which is 675 by 10 to the minus 9 over 1.8 by 10 to the minus 4 equals 0.00375. So that gives us theta is 0.21 degrees. But for part B, if A is 1.8 by 10 to the minus 6, so it is 100 times smaller, we now have that sine theta is 675, our wavelength there, by 10 to the minus 9, over now 1.8 by 10 to the minus 6, which is 100 times the previous one, so 0.375, and that gives us theta equals 22 degrees. So again, we're seeing the relationship between a narrower slit making a much wider pattern. Now, number 6, wavelength is 688 nanometers. A is 6.73 by 10 to the minus 6 meters. Distance is 1.85 to the screen, and we're told it is the third fringe. So again, A sine theta equals m lambda. So sine theta equals m lambda over A is 3 times 688 by 10 to the minus 9 over 6.73 by 10 to the minus 6, and that gives us 0.307, so theta is in fact about 17.9 degrees. Then tan theta is 0.322. Notice, because theta is not that small, sine theta is not really that close to tan theta. I mean, it's close, but they're not exactly the same. So we have y is d tan theta. Remember, for our distance d here, we're looking at y over there. That's theta. So it was 1.85 times 0.322, and that means the distance would have been 0.596 meters. Now number 7, we have a wavelength of 500 nanometers. Slit width is 6 by 10 to the minus 6 meters. Distance is 3 meters. And we are interested in the intensity at 15 centimeters. So first thing we're going to do is find theta. Now we know that tan theta equals 15 centimeters, which is 0.15 meters, over 3 meters is 0.05, and that gives us theta equals 2.86 degrees. So then sine theta, again, is 0.05. So for that small angle, you can see they are about the same. So now, since we're looking at intensity, we need the intensity equation that has alpha in it, and alpha was pi a over lambda sine theta, which is pi times 6 by 10 to the minus 6 over 500 by 10 to the minus 9 times 0.05 equals 1.883. Now at this point we turn our calculator to radians, because the intensity at P divided by the intensity at the centre is sine alpha over alpha squared, where alpha is in radians. So we have sine 1.883 over 1.883 squared equals 0.9517 over 1.883 squared, which equals 0.505 squared, which is 0.255, or 25.5% of the peak intensity at the centre. And now very quickly, number A. So we have the same equation for a single slit is what we can use for diffraction from a hair, and we've got m equals 1, so the first dark fringe. We have a wavelength of 650 nanometers. Distance to the screen is 187 centimeters, and the distance from the centre to that first dark fringe was 2.2 centimeters. So again, small angle approximation, sine theta is about equal to tan theta, which is y over d, which is 2.2 over 187, which is 0.0118. So now A is going to be m lambda over sine theta, which is 1 times 650 by 10 to the minus 9 over 0.0118 is 5.51 by 10 to the minus 5 meters, or we could write as 55 approximately microns.